Question 26 asks us to write a proof, and we're actually going to change this to a 2-column proof. Asks us to write a proof to prove that GL, which is this side right here, is congruent to IL, which is this side right here, and that HL, which is this side right here, is congruent to JL, which is this side right here. Now, I wrote 2 lines for those, but they're actually all 4 congruent, and we'll prove that in future proofs. So we're going to start by creating our T chart. Okay, actually, let me do this as a straight line. I like it better when it's a straight line. Okay, so there's our, there we go. So we're going to put statements on the left and reasons on the right. Okay, so the very first thing that we're going to do is we're going to put GH congruent to JI. We know that GH is congruent to JI because we know it's a square. So this is the given or definition of a square. It's not exactly given, but we'll call this given / definition of a square because it's part of the information we're given, but it wasn't exactly explicitly stated. Okay, step 2 is we also know that opposite sides of squares are parallel. So I also know that GH is parallel to JI. GH is parallel to JI. And this is because opposite sides of squares are parallel. Okay, so if I have parallel lines, then I have some special angle relationships. So I know that angle HGI, which is this angle right here, is congruent to angle GIJ, which is this angle right here. Okay, so I know that angle GHI, or HGI, angle HGI is congruent to angle GIJ. Those are alternate interior angles. Alternate interior angles theorem. And I also know that GLH and JLI, these 2 angles, are vertical angles. So I know that GLH is congruent to JLI. Oh, sorry, we want angle JLI. And those are vertical angles theorem. Okay, so now I should be able to prove that these 2 triangles are congruent because I have an angle, I have another angle, and I have a side. So these 2 triangles, triangle GHL, should be congruent to triangle IJL by angle side congruency theorem. Angle side congruence theorem. And now, if those triangles are congruent, then that means what we were ultimately looking for, which was GL here congruent to IL, and HL congruent to JL, those pieces are congruent by CPCTC. So I can say the final step, the step I was trying to prove, GL congruent to IL and HL congruent to JL by CPCTC. And just as a quick refresher, CPCTC means corresponding parts of congruent triangles are congruent. All right, there's our proof.